Well, Anthony, what's the topic of the day?
Well, let's talk about I/O fencing basics. We'll go through basic functionality and how this all works, how it all plays together, and see if you can't follow. We start out with 2 cluster nodes, same as before, nice and easy. Have our base heartbeats to connect them, so we're getting our cluster status. Draw the red heart.
Well, you have to have the red heart.
Well, you don't have to, but it's always a nice touch. You have your storage and your networking. So each of these nodes are in the cluster. They've joined. One of them starts up an application. The need for I/O fencing is the fact that when the cluster is up and working, each node understands what's happening with that application on both sides, both nodes. If something was to happen to our heartbeat, there would have that disconnection. We call that a split brain condition. Split brain is when both cluster nodes think that they're the only surviving node. And as such, they try to start that application up. That's what high availability is all about. Problem is without fencing, there is nothing to coordinate that membership arbitration. So what we do is we ask for 3 coordination points. They can be either network-based coordination points or they can be coordinator disks. In our case, we're just going to leave them associated with the network. When the systems start up and they join the cluster, they have their own membership on these coordination points. We have the green node here, and we have the red node. They start up, they join the cluster, they put their own reservation out or registration out there. If something does, like we had said, happen to the heartbeat, now rather than them assuming they're the only one alive, they're going to go through a race condition. And the race condition is to try to identify the other node in the cluster and remove their reservation from the coordination points. So in this case, the green node is going to go through and it's going to remove one of the red node's reservations. The red node's going to do the same thing for the green. What happens is we end up with a condition where one node has half of the coordination points with its reservation still on there. That node stays online. The other node only has 1 of the 3. So it doesn't have enough to stay online. It removes itself and reboots.
So it has to have more than half. Is that correct?
Half or more, yes.
Half or more? So are you saying that the coordination points, I could get away with having 4, or should I have an odd number?
You should have an odd number. That's a very good question. But you need to have half or more, meaning that this green node could have had all 3.
Right, understand.
Okay.
Okay.
When this box comes back online, it reboots. If it can't join the cluster, if it can't connect to the heartbeats, nothing happens. As soon as it can join the heartbeats, then it puts its reservations back on the boxes and joins the cluster. Now, once again, it's a target for that application to fail over.
Okay, and then that other coordination point up there would have the green one as well, is that right? So like when it kicks off the application, it would have taken all of them, is that right?
No, depending on how the race wins, more often than not, the winner of the race wins all 3.
Gotcha, gotcha. Okay, well, cool.
But for an example, I removed 1 from the green node, just to see.
Excellent. So what this is doing then is it's preventing the situation where you have both nodes running the application at the same time. Correct. And what's wrong with having that happen?
Well, a split brain condition is an issue in that having both nodes with the application on at the same time is touching the same disk. So you're going to end up with either corrupted disk for the data disk or corrupted application binaries, depending on what's failing, or both.
Well, this certainly makes fencing a whole lot more clear, in my opinion. This is just your basic fencing. This is what fencing does, and it helps eliminate the split brain. So this should explain what fencing does with a cluster and in terms of how we do it with VCS.
Absolutely.
So thanks a lot. I appreciate it.
Thank you.